In this lecture, we will find determinants and matrices by the determinant theorems. And we have a few examples here. Let's look at this one. Suppose that one has found the determinant of this 3 by 3 matrix. You may put 3 by 3 matrix is 2 already. So ask us to find 9, 4, 7, 2, 1, 8, 10, 5, 6. Ask us to find out the determinant of this one. Okay. Comparing those two matrices, we know here is what? 2, 1, 8, 9, 4, 7. And here the second row is 2, 1, 8, 9, 4, 7. The last row is the same. So basically, if two rows, first row and the second row are exchanged, then we can immediately get just negative 2. Here was positive, and then here will be negative. Why? Because, by the determinant theorem, what does it say? It says that exchange any two rows or two columns, doesn't matter. If you change here is two rows are changed, then the sign of the determinant will be changed. Okay, so the first one is pretty trivial one. If you know, of course, the determinant theorem. If you don't know, your life is hard. You see, you have to do is to recalculate this one. But since this one we already found the value is 2, the determinant is 2, and then those two rows are changed, you get the new matrices, new matrix, and then you just need to switch the sign. So the first one is an easy one. Is the second one also easy one? Is easy one if you remember the determinant theorems. Look, down here we have the second column is 0. The determinant theorem says that if one row or one column is 0, then the determinant is 0. So, you do not have to calculate really. You just put 0 right here. 0 equals 0. And why? You may actually, in this case, you may do a little bit more to see why. You see, write column 1 one more time here, column 2 one more time here. The red product 6, 0, 2, you get 0. 0, 2, 2, you get 0. And then you see this 0 we have not used, but is right here. 0, 6, 0, you get 0. So the red product is 0, so is the yellow product. You see down here, you have this one is 0, so you do it 0 in this way. And the element right here, this one is 0, so you do the yellow product, you get 0. For this one, it goes there. And when you do the yellow product, you still have a 0. So one row or one column, here is this column is 0, then the determinant is 0. Alright, that looks like an easy one. Now, here I wrote 7 here. Actually what? Actually I should write 3, huh? Example 1, 2, 3. Alright. Now here we need to find out the determinant for 158, 058, 003. We got to use the determinant theorems. And if you have noticed, the lower diagonal, they're all zeros, then this determinant basically is the product of the value of this line only. Okay? Yeah. So that's what determinant theorem says. Of course, you may do like, again, write column 1 one more time, column 2 one more time here, 550, 550. You can calculate that. And then you will see 153. 153 is the product of this diagonal. Then you have a 580, you got 0, because the product contains a 0. Okay? And then 800. So the red product end up with only the product of this diagonal line. And the yellow product, you have a here is 0, so 0 times any number is 0. And you have this yellow one, so 081. And then you have this one, 305. This 0 comes from here. Okay? So basically the products of yellow products, they are all zeros. So the determinant theorem basically says what? If the lower or upper, here is the lower triangle. If the lower or upper triangle elements are all zeros, then the determinant is the product of elements on the diagonal. That's it. Okay? So basically, when you see a lower diagonal or upper means what? Means somewhere here. If here, you know, we have a lower triangle is 0. So then it's 1, 5, 3. Okay? 153, 1 times 5 times 3, that's 15, that's it. Okay? So this one looks like an easy one. Alright? Please review this lecture. I'll see you next time.